Hello everyone, welcome to Fun Code. This is Gajanan here. So today we are going to look at the majority element question. So I guess everybody of you is fine. Let's not waste our time and let's jump directly to the question. So the thing is, we have been given an array of nums of size n and we have to return the majority element. The majority element in the array that appears more than n by 2 times. You may assume that majority element always exists in the array. So yeah. So it is very basic question. For example, I have been given an array like I can say 1, 2, 2, 2, 3, 1, 1, 1. So in this array, I can clearly say that 1 is appearing 3 times. Okay. So uh, the element appears more than, okay. They have said that the elements appears more than n by 2 times. So yeah, 1, 1, 1. So the total number of elements here is 7, right? So in that R1 appears 4 times. So it appears more than n by 2, that is 3.5 se zyada. More than 3.25. Okay, so it appears 4 times. So basically we have to return this 1. So yeah, the question is pretty simple. We have to give the answers in the most optimized. Okay, so we will like go from the brute force, then the beater and the optimal approach, right? So the brute force approach is by basically counting each element, how many times it appears, and then comparing and then seeing which appears the most of the time. So here we would require O of n square time complexity. So this is not at all efficient. If you want me to give you code for this, just comment down code. I will link the code for this one. Okay, I won't go into the brute force that much because it is very simple. Like you just have to implement two arrays, like two for loops, and then you have to go one by one. Like if in the first, like in the first for loop, I have fixed like the first element, then I would look in the iterate in the entire array to look how many times that first element appears, and similar for the second, third, and everything. So like that, I would count, then I would compare, and I would, yeah, I return the max one. Okay. So in the better approach, what I am doing is I am using a hash map to store the unique elements and their count, that is occurrence, right? And so by this, if I would like, and yeah, this thing here, count is n by 2, count is greater than n by 2. I can use this for my best, and yeah, I can use the hash map, and whenever I encounter that count occurrence of a particular number is greater than n by 2, I would definitely return it. I would directly return it without any second thought, because the inputs the test cases we have been given always has a majority element that appears n by 2, more than n by 2 times. Yeah, so I can use this for my benefit and go with the solution. I'm saying if this count goes above n by 2, right? N is the size of the array, right? So if this count goes above n by 2, what I would do is I would return this key. Okay, key or the element, whatever you want to say. Yeah, so the approach is quite simple. Basically what I am doing is I am just looking for that like count greater than n by 2 in the hash map, and wherever I get it, I'm just returning it. So basically, let's move on to the code part. You would more understand it more there. Okay, yeah. So this is the problem, majority element problem, and these are the sample inputs. Basically, I guess you have understood right now what I was going to tell you. And yeah, we have to solve this in linear time and linear space. Basically, this is not the linear space. Here I am using O of n time complexity and O of n space complexity. But we would move on to that solution later on. Okay. So basically, first let's implement a hash map of integer, comma, integer, right? Then I will name it map, then new hash map of, okay, okay. So after that, what I want is I want to write a for loop, right? Before writing the for loop, let's write int res is equals to I will write it as num0. If there is nothing, like if this is the condition, like I have given only one array, this is my array, I would have to return this. There's nothing to compare, right? Okay. Now let's write a for loop. Okay. So in the for loop, I would write int I is equals to 0. This is the basic syntax. I is less than nums dot length and I plus plus. Okay. So this is it. So if map dot contains key, right? If my map contains that key, what key? Nums I. Okay. If my map contains nums I, what I would do is map dot put. Okay. What I would do? Map dot put nums. Okay. Nums I, comma, map dot get nums I. It exists already, right? So I would get that and plus one. Okay. You understood. Basically, I'm updating the value for this key and then in there. Okay. And then I would check if map dot get nums I, the value for this key, I'm see map dot get nums I. So I am basically I updated the key and then I'm checking if map dot get nums I, basically the key now for that is greater than n by 2, right? Is greater than, let me do it, nums dot length divided by 2. Okay, if it is greater by 2, what I would do is return, okay, not return, raise is equals to what? Nums I. Okay, hope you understood this. Okay, raise is equals to nums dot this. Else if it doesn't contain the key, what I would do is map dot put, simply I would have to put this map dot put nums I, comma 1. Got it? Okay. And now at the last, I would like to return res. Res is result. Basically, I have short form for result. I've written it. You can do anything. Let's try submitting this. Okay, I've run this. Okay, this is accepted. Let's try submitting it now. Okay, yeah, it is submitted. So basically, this bit's only 7.63 because it is taking more time, sorry, more space complexity here. So here it is written that could you solve this problem in linear time, that is O1, O of 1 square. So we would move on to the optimal approach right now. Okay, the optimal approach for this question, I would try to explain you. Okay, hmm. So the best approach for this is Boyer-Murray voting algorithm. It uses O of n time and O of n space. So basically, I would try to explain you it in a simple terms. Basically, you can think of two people contesting elections, right? So there are total 10 votes. This person has got 4 votes. Okay, this person has got 4 votes and this person has got 6 votes. So okay, and the voting was like this. The first vote was for A, second was for A, then for B, then for A, then for B, B, A, B, B, B. So what I would do is, if, see, right, if the first vote is for A, while counting I would say okay, A has the vote. Okay, so A is 1. Okay, then I would go to the next. Okay, again A, so I would just remove this one and I would say okay, A has got 2, but when it comes to B, right, it is coming to B. Okay, so now how much lead is to A? A is leading by 1, so what I would do is remove 1 from here. Okay, so by removing 1, what I would do is okay, 1. So again there is A, I would say okay, I will add 1. Then again there is a B, so I would say remove 1. Again a B, okay, A is 0 now and B is 0, they are on equal terms. So again A, okay, A is leading by 1. Again B, okay, it gets back to 0. Again B, okay, now the A is nowhere. Now B is at a lead of 1. Okay, and again B, he this one B. Okay, so at last B is at the lead of 2. I can get by this algorithm. So it is very basic. Just understand that I am manually counting it like one by one. I am comparing directly there and there here. So what I did was A. Okay, if it is A, if I'm getting the similar candidate, I would increment it. If I'm getting another candidate, I would decrement it. Same candidate, increment. Different candidate, decrement. Okay. So this is very simple, but you have to like get it. Like the intuition is a bit complex. Just if you think on this problem, you would get it somehow. And if you don't get, there's no problem. Look at other solutions. Look at this algorithms. This is a Boyer-Murray voting algorithm. Basically, they have researched on it and created that algorithm. It is not easy to get that algorithm by yourself. So just look at the solutions, try to understand these algorithms, and then implement it. Okay. Directly don't copy the solutions. Just when you look at the solution, just have this approach in your mind. You are looking at the solution, but then you go through the solution, you copy the approach, and then you think on it, and then you code. Okay, directly don't copy the code, it won't be useful for you. So yeah, now we have to code this one. What? Okay, the Boyer-Murray approach. So in this approach, what I will do is I will take two integers, right? Integer count, I would count, basically I have to count, and the second is candidate. I have to check now which candidate. Okay, so candidate, let's initialize it with -1. Okay, so for writing a for loop, int I is equals to 0, I is less than nums dot length, everybody knows this, and then I plus plus. Okay. So here comes the tricky part. What? Same candidate in the voting list, what I would do, increment. If different candidate, decrement. And when the candidate is becoming 0, what I did was I changed A to B, right? I gave the vote to B, and yeah, so B started counting started for B because it gained the lead. Okay, so if the count becomes 0, what I would have to do is, if the count becomes 0, I would have to change the candidate to the respective candidate, and also I would have to increment the count. Okay, basically I did nothing, I just coded the part I explained you previously. Okay, then if nums I, that is, if this is equals, let me write it here, if this is equals to the candidate, what I have to do is count plus plus. Everybody knows this. Okay, but see, when when it is different candidate, right, I have to decrease the vote, I have to decrease the margin. So I did that, count minus minus, and after this, whoever candidate would be above in the margin, I would like to return that candidate, right? So yeah, this was for the previous solution. Let's try running this if we have any syntax error. Okay, okay, okay. Basically this should have been a comma. Okay, this has been accepted. This would probably be submitted. Okay, so this is the most optimal solution here, right? Okay. So once again, I would try to explain you fast. If you didn't understood it, just catch up right now. So basically what we did was, this were two people, right, contesting elections. So one had 4 votes, one had 6 votes, and the total votes were 10 votes, right? So basically, to declare majority, we need n by more than n by 2 votes, right? So for more than n by 2 votes, we would like count, we would have to count, right? Basically, so what I did was I initialized the candidate with 1 is in majority. Okay, the first candidate is in majority, so A has 1 vote. Okay, ठीक है. After that, A has 2 votes. Okay, then B has 1 vote, so the lead is of 1. I would remove A's count minus 1. Okay, so now A is on one lead. Okay, A another, A is on two lead. Okay, I got B, A is on one. Okay, basically subtracting and adding, and at last I would get the candidate with more votes, majority votes, right? Okay, the one is in margin would be left at the end. So I would just basically written that. So it is basic question, just you have to intuit there. Yeah. So I would just suggest you practice more and more. You would get this type of questions very easily. So yeah, thanks a lot for watching this video. Hope you like this video. If you have any problem with my explanation, please let me know. I would like to improve my explanations. And also, if you are new to this channel, please subscribe. And yeah, this is it. I am like solving all the DSA problems in a series. So basically this is the third problem of our array series. If you haven't watched the other two, just go and watch it. Thank you.